F-sharp tapas. I love some good tapas. So what are you going to be covering from the description? It seems like you're going to cover some really interesting IoT and F-sharp and Spark. So what are you going to cover on the talk today?
So because Louis Quintanilla did such a great job with his Spark presentation, I'm kind of going to whistle past it a little bit, mainly in the interest of time, because the IoT example is a really rich example of really concise, what I would think of as elegant code. Even though it's a small proof of concept, it accomplishes a lot with just a few lines of code. And I'm going to show a little bit about how I got into the F-sharp ecosystem and how a lot of folks that come to F-sharp will come from C-sharp because they're already in the .NET ecosystem. And I have lots of C-sharp experience, but I really came more from the R world and that, the R and Python kind of ecosystems. And I want to show the direct line that kind of gave me my first real hook into F-sharp that was like, aha, this really is something familiar, but really compelling and different.
Oh, nice. And I really like how Gina put it, that we have such a great community for F-sharp. It's like a small community, but people are so invested in each other's success and making people successful. So it's really great to hear that as well.
Absolutely. I'm going to be spending some time talking about some bugs that I encountered and some, I would call it self-inflicted wounds while I was learning, and the help that I got from both the Meadow community and the Meadow developers that have their own Slack server, as well as the F-sharp community, really helped me get past some of those roadblocks and got past that initial kind of point of friction that you have in the learning process and really open things up. And I literally couldn't have done it without them. So I'm definitely going to be showering them with some praise, because it's not just the platform that Microsoft has built. It's also the ecosystem and the community that really has brought a lot to the plate.
Awesome. So we are at time. So I think we can get started with your presentation about small bites from the cloud to the edge.
Outstanding. Thank you so much. So this is, as I was saying, a bit of a lead into my learning of how I got drawn into the F-sharp world. I'd had a few blushes and brushes with it earlier in my career, but it didn't really connect until I saw the interop story. So I'm going to show two interop stories that really connected for me. One is out of the R ecosystem, and the other is with the IoT and working with the C# libraries that Wilderness Labs had built for their Meadow platform. So I'm going to go ahead and jump in and talk a little bit about kind of where I come from. The reason why I was asked to do this talk was because a blog post that I wrote called What the F-sharp is Next. And of course, during COVID-19 downtime, and I was on the bench from consulting, I spent a lot of time researching and thinking through this disconnect between the analytic world and the operational world in terms of the code bases. And I really wanted to unify that in terms of the way that I was approaching things. So I went all the way back to looking at some of my early days and some of the IoT stuff that I had done. And my career started, and as you can see in this image here, working for Bob Moog, who's the inventor of the Moog synthesizer. And the big picture in the middle there is the memory Moog keyboard that I worked on that had a Zilog processor that was a microcontroller that was doing a lot of stuff under the hood. And we were doing a lot of modifications of that and also building firmware and software and experiences for users that were in that realm. And I moved on to working in enterprise and larger scaled systems, but still had a foot in IoT and things like automotive telematics and occasionally healthcare and entertainment and the things that you do as you move through the consulting world. So that was essentially my background, and I talked about this in this blog post, and I'm going to give the 2-minute version here, which is I started in the Java ecosystem, and through that had exposure to Groovy and some Scala, and the Scala carried forward into my consulting when I was working as a Microsoft Gold Partner consultant. And that was the experience where I really started transmuting into using R as its own workload, as a user-defined function inside of Spark, where the Scala workloads were beginning to bog down over really long periods and becoming rather fragile, and breaking out the Spark workload into a user-defined function made it a day-long process into something that could run in just a few hours. And at that point, I was exposed to ML.NET and what was going on with the Spark interop that was being built by Microsoft, and it had those same characteristics, that even though it had an API that was very idiomatic to Scala, it produced a workload that was actually a worker that was going off and working in the CLR directly within the worker nodes themselves. And that to me was very familiar to what I was doing in R. So that wasn't quite F# yet, but it was the beginning of me seeing kind of a different way of looking at how to build parallelism into doing these large data workloads. So as I went, made more forays into doing more things in the full stack realm and working with Android and with some IoT projects, there were some Arduino projects involved as well. It was that realization that I think a lot of us have, which is it's a polyglot world. We're dealing with a lot of technologies and a lot of ecosystems, and you have this kind of element of perishable skills that you have in your head of all these different languages that you have to know enough of to be able to accomplish a certain thing. And then once you step away from that domain, it feels like the perishable portion of that knowledge is lost, and you always have to go back and revisit. And so what I was looking for was a language and an ecosystem that really could carry the water in a lot of different domains. And the phrase that I was using was from the cloud to the edge and back. So that was really where I started with F#, and I started with learning going on to online courses and taking the kinesthetic approach of actually learning by doing. And as soon as I got through some of those online courses, I immediately started trying to solve my own problem, because I figured that would be the way that it would stop folks that are conversant with the F# interactive. This is our studio. I'm kicking off a process, and you can see inside the console here that it's running the code and giving some error messages back, and then it's doing the render of the visual off to the side. And this is for really rapid prototyping and developing things, and eventually this gets converted into a web page. But what's happening is the HiCharter library, which is a JavaScript library, is actually being controlled by R. And you can actually see down lower here, there's actually some HTML that's being brought to bear, but it's actually informing how the tooltip is being built. So there's this interop that's already there in the R ecosystem, where R is talking to HiCharter, and HiCharter is doing things with JavaScript and with HTML to actually render this. So I wanted to do the same thing within F# to kind of bring it home. So I have this exercise where I went through to try to find other places where HiCharts were being used, and HiCharts makes a .NET library. And HiCharts is like Plotly and other visualization libraries that it has a large user base, and it's used for a lot of different things. They use it for stock and analysis. I used it for medical analysis for a healthcare client. So it's one of those things that it's a kind of a chameleon and kind of runs anywhere. So I found that WebSharper had an implementation for it. And this is actually an experiment that someone had built in F# called FizzPlot that is designed specifically for working interactively. And so you can see here, and I'm going to go ahead and just run this in front of you, that it's building this plot and rendering it right in front of you. So you exactly within the RStudio experience where the code was being run, and you could see it happen in the console, and you could see some feedback. If there were errors, you would actually see them in the console, so you can remediate and rerun. And this inner loop is very familiar to me, and this was the first real aha moment that I had with F#, that you have this very concise syntax, you have a very immediate and gratifying inner loop in the editing environment. And so you can do things here that's very familiar to what I was able to do within the R environment, and then I was off to the races. So the first thing I wanted to do is I was looking at the way that this was applying themes, and the way it was applying themes in the RStudio is exactly the same way that you can apply it here. The syntax is different, but it's the same thing where the code environment is basically projecting into the JavaScript runtime, and JavaScript is basically updating what's happening in the web page. So this was the beginning of, oh, I want to find this thing that's familiar to what I had used before and bring it over. So I'm going to go and find, this is the HiCharter library where it has all the different versions of different themes that can be applied. And this is JavaScript that's embedded inside of R. So what I did is I extracted that JavaScript out and brought it to, instead of just the 3 that it offered, which was listed here, gray, dark gray and then default, which is what falls through, and it falls all the way through the logic. And I added the other JavaScript objects that came out of the PyCharter library so that I could take and apply them here. So all I had to do was add this to this JavaScript library, recompile my own version of the DLL, and I was off to the races. All I had to do is then use those name labels, and it could remap what was actually showing in the display, and then eventually, of course, you can work it out to put it in its own visualization. But this was that inner loop of being able to do some experiment and do discovery, and do it in a way that's really concise and really friendly. And of course, I was looking at the F# code behind the scenes that was built for this particular library, and I couldn't believe that it was as small as it was. And that was that next step of drawing my eye forward in the F# ecosystem. So I'm going to switch back and talk a little bit about the second project. The second thing that I wanted to do was, where else can F# run? And of course, the ultimate to me is being able to move out into mobile and out to the edge in IoT. And at the time that I was asking myself that question, Wilderness Labs was actually doing some of their own work for supporting templating for F# and for VB on the Meadow IoT platform, which I'll talk about in just a minute. But at the same time, there were discussions going on about aerosol transmission of COVID. And so I had a friend that had a commercial CO2 sensor and had gone into a gym to see if he could go there. And the CO2 readings were like 1,500 parts per million. And you can see here that the research actually shows that 750 really is kind of the threshold at which they're recommending that you start bringing fresh air into a space. So we ended up having a conversation about somebody should be doing something about that. Someone should build something. So I decided to actually use the Wilderness Labs Meadow to do that. So I'm going to show the Wilderness Labs Meadow in a summary view, but you're also going to see it in a live demo here in just a minute. One of the really nice things about the Meadow is that it's not just one processor. It's actually a full solution board. So you have this, and I'm going to go and find this. You actually have this ARM processor. It's the STM32F7 that is a fully capable microprocessor. And there are other coprocessors along with it on the board that allow it to do many other things. There's battery charging, there's Wi-Fi, there's Bluetooth support, and it has, as you can see, a high degree of I/O that allows you to connect a lot of different things and for it to do a lot of different functions. So it's a general project platform, but it's not just hanging out there. It has a lot of support for other peripherals and devices, and they basically are piggybacking on that ecosystem around the Raspberry Pi and the Arduino form factors. And so they support the SparkFun and the Adafruit peripherals and so forth. So they made it work well and play well with others, not just hooking it up in hardware, but they actually built drivers for them. So you can get these off-the-shelf components, do a NuGet pull for the C# library that supports that driver, and you can just go. And that to me is really this amazing kind of propelling kind of effort that comes, it's open source, but it's also a commercial effort. And so all these components that you can find anywhere online, you can take and add to this project board and write idiomatic .NET code. And I'm going to be showing the F# version of the CO2 sensor operating here in just a moment in my own test rig. So this is a CO2 sensor. You can see here in these two little slots here, there's a little tiny sensor on a board that's about the size of a quarter. I'm also running a relay that's relaying in a dual fan operation that actually is pulling in fresh air and sucking out air inside of a test enclosure, which I'll show in a moment. So this is an overhead view of the entire rig, and I put an enclosure over the top of the project board with a display that's going to show the parts per million that's being read in the CO2 sensor, and this relay that's off to the side that's turning on these two fans. So that's the high level, literally, of the rig. And whenever I switch to the next camera position, you'll be able to see a bit more. So if you look at the lower part of the screen here, you'll see that I've got some project views here, both of the side view and an overhead view. You can see how everything is wired in. I'm looking at the time, making sure that I don't run over, so I'm doing okay. But the enclosure actually sits over the top of it so that the air stays enclosed, and I have a little CO2 injector that's a bicycle tire inflator that actually allows me to put a controlled burst of CO2 into the space. You can watch it kind of level up and see the events trigger in the console, and then the fans will turn on with the relay and will eventually clear the air, as it were. So before that, I want to show a little bit about the actual boot up process here, because this is what's really interesting to me. Is this is very close to running like running a debug for an Android or iOS device, where you have a USB connection to the board itself so that you can actually get some debug information back into the editor. So you can see that this relies heavily on mono, and they've done some amazing work. The folks at Wilderness Labs are the same folks that helped create Xamarin, so they definitely know how to make interop work with the outside world. And so this goes through a series of checks to see all these DLLs. It's actually putting DLLs directly on the microprocessor. So you're actually running .NET natively. This isn't something where I'm running, in an emulator on the machine and pushing to the display. It's actually pushing the code and running it on that STM32F7. So I'm going to switch back to this, and I'm going to lower the hood on, and there we go. So I'm going to plug this in, get the power to the board, close the lid. You're not going to see the fan quite yet because of, I want the CO2 to kind of build up and for the loop to trigger for turning on the fans, and then I'll show how that works and how it dissipates. So this is the boot up cycle, which is relatively quick. And now we're getting basically a debug stream from the console write lines and printfns out of the code that you see above. And it takes a moment for the sensor to initialize and start talking to the microprocessor and for it to start displaying. So here we go. And we'll give that a couple of cycles for it to start registering new values. I'm going to inject some CO2 into the enclosure. You can see the CO2 value going up, and this is registering in parts per million. And if it goes over 750, it starts to remediate, and then once it gets below 650, it then shuts off again. So pretty straightforward. I'll do another injection and keep pushing it a little bit so it actually has a few more seconds to run. And this is running on a 2-second cycle. But of course, in a production environment, it would run every minute or run every 2 minutes. So again, the ventilator goes back off and it's going back into the blue zone. So you can look at the fan and see that it actually triggers, and you'll see the relay will So I'm going to let that run and let it idle in the background. The valve will continue to emit some CO2 because that's the way those bicycle tire inflators are. Once you pierce the head of the cylinder, it just continues to leak CO2 until it's empty. But I'm going to go through the code and actually show how this works. And we'll start with the bottom and work our way up to the top. So you can see here I'm sampling the value every 2 seconds. And that value is being emitted into this observer and going through the process of actually extracting data out of this. Now, this particular sensor, the CCS 811, actually gives you 2 values. One is the CO2 value, which is the first value, and the second is a VOC value, which is kind of a more general term for like the amount of particulate that's in the air. I'm only interested in the CO2, so you can see here I'm actually doing a match that's only pulling the first value out of that tuple. And I'm going to talk about the signature for that and how the Wilderness Labs ecosystem did a really good job of building a very deep and useful model, including the units definition that was first a stumbling block, but then became really enabling. And I'll talk about that in a minute. And that's part of the support that I received from the community to really kind of get through that process and understand how that works. But this is the idiomatic part that you'll see in a lot of F# code, where you have a match expression where you want to go through a match of value to return something out. And this is to return the value back to that display. And here, of course, the base value, whenever everything is fine, I'm giving back a sky blue. Here I'm using Burleywood, which is kind of like a Los Angeles smog kind of color. Orange is kind of between that smog color, and there's Los Angeles for you in the background. And of course, once you get above 2000, I just made that red. These values are arbitrary. The 750 really is the value that I care about, and the one that's kind of based on that research. But here I'm just setting some thresholds so I can actually see that the loop is actually working and is actually getting new values and changing what's displayed. So I'm going to pause for a moment and go back up to the top and look at what this loop is doing whenever the ventilator is turned on. You've seen that happen whenever the console actually emits the value that the ventilator is on. This happens whenever this value goes above a certain amount, and it basically spawns a separate thread and runs that thread in parallel while it continues to emit the new data values out of the observer. So this to me was what was really compelling about the Meadow, is that you can run a multi-threaded application in it, and it's very kind of like garden variety idiomatic code to get it to run. So basically sending an async start and then wrapping the function in an async, and it just works. And there was a little snag that I hit in that process that I want to get to before timeout, but where I stubbed my toe a few times and got helped out by both the Meadow community and the F# community. So there's a couple of state management things that I'm doing here with these mutable values, these Booleans, and that's the thing that basically says, while I'm in the loop and it's above the 750 value, if the fan is already running, then don't trigger the event again. And that's what this is. And the basic idea here is, once you get used to the domain, this is very readable. Like if the new value is greater than the threshold value and the ventilation is not on, then toggle the event. So that ventilation is on Boolean is what prevents it from continuously sending events while the fan is running well above threshold. So it creates a very clean exit for the logic. And even inside the loop itself, there's another evaluation that goes on that basically is looking for whether it actually sets ventilation is on to true, so that the observer doesn't send any more events. And this relay 1 is on is actually something that was provided by the Wilderness Labs Meadow in their model that basically says, oh, hey, this is a relay. We have a model type for this relay, and therefore we're going to provide this thing that says is on, that provides a Boolean, so that you can evaluate whether something is on. And so this is that thing of, instead of having to have it toggle on and off on a hard cycle, you can simply continue to evaluate for the state and continue to loop through. So it creates a very smooth experience, and then you toggle off whenever you exit out after it goes below the threshold. So I've been talking about these thresholds, and I set them up here as these immutable values. And the threshold to turn the fan on is 750 parts per million. And you'll notice that I actually set this very verbose explanation for this, and there's a couple of reasons for that, and I'm going to get to that in a minute. The second value is what the clear threshold is once it gets below that value. And a lot of HVAC systems actually work like this, where if you set your thermostat to 75 degrees, it actually doesn't cut off until it goes to 74, those kinds of things. So this is similar to that, where I wanted to bring it all the way down into the blue zone before I switched the fan back out again, and then allowed it to creep back up to 750 before it would trigger back on and push it back down. So the latest CO2 value was just a nominal value because the sensor itself starts at 400. And the previous CO2 value I set at 0 for a specific reason, and this is where I got caught up in one a specific hang within the evaluation here, where basically if I was looking at this old value and it was null, it was actually causing the process to hang. And so I could actually just do, because of the type system, it has this function called hasValue and gives a Boolean back. So if it had a value, then I would do the assignment into the previous CO2 value. Otherwise, I would leave it at that 0 that I had originally set. So it would always evaluate because there's a 0 there. It's not a null. And that way, when I'm running this function where I'm only emitting the new value to the display whenever the previous value is different than the latest value. So If they're the same value, then I don't bother telling the display to do anything. Right now, while I have power on the USB port, it's kind of an infinite power supply. But when you're running on battery, and eventually there's going to be times where you want to have a quiet time and not make the processor do this repetitive work. Right now, I'm using a very short time scale on purpose for the demo. But when you get into time scales of minutes and hours, and you want the battery to last weeks or months, you have to start being concerned about whether or not you're telling the processor to do certain functions and wasting cycles. So this is a really simple proof of concept, but I wanted to start at least including a little bit of that to show that there's ways that you can actually make it sensitive to that. And the thing that I really like about this is that all of this is expressed with less than 75 lines of code. That's probably the biggest lie you're going to hear here today. And that's because there is a ton of code that's behind the scenes that was produced by Wilderness Labs that gives a tremendous amount of functionality that I can just access very easily within F#. So it's all written in C#, and they're all libraries that I bring in. But if you look at the way this is built, I'm actually just declaring, Meadow Foundation sensors.atmospheric, but then I import .ccs811. And that's a special thing about Wilderness Labs Meadow, is that they don't overburden you with like a huge library. You only import the libraries that you need for the specific sensors that you're using. So when you go and you do the open or the using, you'll see it's generic, but you're just going to be accessing that specific sensor that you've imported. So it's a very thoughtful model. It's very robust. It has a lot of support both from the F# community. I've got a tremendous amount of help from them, even folks that had no idea of how the Meadow actually works. They were just seeing what I was trying to accomplish and actually helped me get past some of the roadblocks. And of course, the Wilderness Labs folks are just really tremendous in terms of not only building a model that works really well for these off-the-shelf components, but also creates an ecosystem that allows you to bring your own device and bring an I2C device or an SPI device that you can actually build your own model, because they've done a really good job of leaving breadcrumbs that you can follow and actually build something behind them. This is one of the projects I have planned. So that's basically the sum total from me, that I knew that I could take this very concise code all the way out to the edge and be able to make it actually run for days. I mean, I haven't run it for weeks yet because I've only been working on it for a while, and I keep tweaking it, so I keep rebooting. But this is one of those things that initially I was stubbing my toe on an async function, and an F# person who has no idea what I was doing within Meadow gave me the answer back in a way that kind of blew my mind and really opened things up. So those are the three things that I'm taking from what I consider to be the start of my journey with F#, which is take the kinesthetic approach and learn while doing. Like just watching videos or just reading a book is not enough. You definitely need to do that as well. But getting inside of that inner loop and working with the tooling, it's very inviting and very rewarding. And that's definitely something I would recommend everyone do. The second thing is find a problem that you've solved before and find a way that F# has solved something similar to it in its own ecosystem. And that way you can make your own connection to the way things operate in that world. And then the last and most important thing is, and if you've been watching any of these presentations, those resources are everywhere, and they're really phenomenal. You can, I've been able to talk to the folks that wrote the books that I've read. I can talk to Don Simon. I can, send messages on the F# Slack forum and get answers back from folks that I've just finished looking at their library online, and they help me pierce the veil. So I would very strongly recommend just to get involved and to start experimenting with it, because it's a very rewarding environment to work in. So thank you so much for listening and for watching me go through all my toys and everything, and enjoy the rest of the conference.
Thank you, Houston, for the great talk. It was great to see your setup there. And let's see some of the comments we got. So our friend Beth was saying what a really nice setup, and it was really cool to see like the cameras and everything that you had there for us to really see the demo really well. So thank you. And there was a shout out from chat for showing that mutability in F# can be used for good at .NET Conf today. Immutable
That's really, yeah. You know what? I should have mentioned that in particular. sorry, the head uh, uh, of Wilderness Labs, he basically said that immutability is actually kind of a hindrance for these limited resource processor things where, and this is, you're talking to the outside world where you're talking to the display or you're talking to the sensor, or you're sending something out somewhere else. You have to have immutable structure. It's kind of based that way. And that's one of the things that I ran into trouble with where I was doing a sleep inside of an asynchronous thread that it was basically after a couple of cycles, it was replicating an overrunning memory and causing the thread to jank. As soon as I started using the async thread and async sleep, then everything really smoothed out. But that was the beginning of understanding that in that ecosystem, mutability, particularly as you're talking to the ports and adapters level, is really an advantage.
Yeah, and we got a question from the Twitch chat. If there is a framework to do stuff like this in an Elmish way without the mutable var. So do you know about that?
So I don't know, but I'm looking at like using Akka.net. I know that Akka.net it's an actor system that people have used with mobile devices, and I'm very interested in that kind of encapsulated function where it using the threading, and there's a coprocessor as well. I didn't mention that, but there's an ESP32 coprocessor that can do its own work on the Meadow board aside from the STM32F7. So there's a lot of opportunity there where it's entirely possible. If you can do it in .NET, I would imagine that you could at least try it with the Meadow because it's very amenable to that. It's designed to be a kind of a garden variety kind of .NET experience, with resources notwithstanding.
Really cool. I really appreciate your talk. It was excellent. And you mentioned that it's a polyglot world, right? And so up
Yes.
next, we have Paige Bailey and Maria Nagaga to talk about polyglot notebooks in the wild. So let's welcome her. And thank you, Houston.
Thank you so much.